Apparently, our field is dying. Developers get very attached to what they build. Like, they become the product.
It's so easy to get hurt.
The overall bar to enter into the field has just gone up higher because of AI. I think it's actually quite a good thing because it pushes us to be even better.
Everything from line 27 to line 39, it's just noise. This is essentially backend code. Why is it in the schema?
And we're live. Welcome back, ladies and gentlemen, to another episode of The Good Thing. I'm joined by, as always, by my co-host Jens. Jens, how you doing today?
I'm good. By the way, I last second changed my mic. Is it working?
Yeah, I can hear you. That's
Okay.
important.
Perfect.
Last minute change, huh?
Yeah, today we're here without our producer. He would ask us to check the mic and everything. And yeah, hi Jacob. By the way, you will later see the footage.
No, funny thing is also, like, I was like setting up my headphones and I was like setting up the mic, and then I was going through the checklist and I was like, damn, Jacob's not here, like our content guy. I was like, I have no idea what to do actually.
Yeah. Also, welcome to the chat. I hope we have some fun people again, like last week. I think last week we had a bunch of fun with some startups, AI startups, going through them.
You want to hear something crazy though about that? Wait, something's happening in my background. All right, there we go. But
Did you get any feedback?
yeah, I got feedback from the startup founder of the text one. You know, the Chat GPT, but it lives in your text. We said that it would die.
Did they feel hurt?
Kinda. Like, he was just like, I don't think it's cool that you're roasting startups and for content. And I was like, I don't think you watched the video, because at the very beginning we said we're not roasting startups. We're just going through it based on what we think in this AI wave. Like, I'm sorry that you felt roasted. And then he was like, but I did like your feedback. We are trying to expand further because we think Apple Intelligence might kill us. So I was like, okay, well, not bad, but yeah, like, he like found me on LinkedIn.
That's what we said.
Yeah, and so, like, I don't know. I actually was having this debate the other day. I was talking with Dax. So Dax posts. You saw yesterday how the whole internet went down, right?
Actually, I was on vacation. No, I didn't see. It didn't bother me, but it's interesting how interconnected the world is. Like one tiny glitch at Google and everything is broken.
It was kind of funny, but basically, if you saw on Twitter, the CEO of Planet Scale, he was kind of just like not roasting, but he jumped on the opportunity to roast Neon a little bit, because Neon's downtime and like availability wasn't always the best during their time. And obviously, our friend Dax, he jumped on the bandwagon a little bit, and he was getting DMs from like the people work there, and it got me thinking. Is that, I don't know. You can help me explain this. Like, developers get very attached to what they build, to the point where it's like them, like they become the product. Like, I don't understand it, because they got really hurt that somebody said like something kind of mean about a product that they built. But I don't know. Like, do you think developers get too attached to their code or to the things that they build? Like, you are not Cosmo. I'm not WunderGraph, even though sometimes we think we are. But what's your take on that? I know this is off script, but I'm just kind of curious.
I think it's a big problem. It's so easy to get hurt when, for example, in pull requests, you write some code and then you get feedback to improve something, and you immediately feel like emotionally attacked. I think that is something every developer goes through, because like I wrote it. It's my code, and yeah, I think that's a problem. I also think, to be honest, if you're a startup and you get roasted like what we did last week, did you really start with a significant problem you're solving? Like, let's be real. When I started WunderGraph in the very early days, it was just me and the code, and it was like, hey, interesting problem. I want to work on it. I want to solve it. It's fun, and you get super attached to the solution by itself, but are you really solving like a massive problem? I mean, the rest of the story. We figured out over the years that we were not solving the biggest problem. So I don't know. It's a tough one.
It's tough, and like if you've ever read about like Buddhism and nihilism, what they try to say a lot in it is like to remove your emotion from everything, just to detach from people, to detach from products, things like that. And I wonder because like it makes sense. Like you put your hard work into something, you obviously become attached to it. And you were attached to WunderGraph SDK. Remember when we were shutting it down? You were affected a little bit by that.
Yeah, I was very much hurt, but I mean, it's normal. You have an idea, you execute it. It's not working the way you were hoping to, and it's it's kind of like your baby. So
Yeah.
if now someone comes around the corner and tells you like, "Hey, Stefan, the landing page of WunderGraph, it's garbage, it's broken, it doesn't tell me anything," but like I don't know. A few weeks ago, we were talking about our landing pages, and we said like, okay, our landing page is also not the greatest, but
Yeah.
what we kind of figured out in retrospect is for snatching away Apollo customers, it's actually
Top notch.
it's the best. You this is one of my biggest learnings. When you are a small startup, you might be thinking to that you want to behave like a big startup. And the well, one big learning for us was just just accept that you're the small startup and just play the small startup role. When we were like super small, I was like, okay, big vision, and we put the vision on top, and we speak about the vision, and we make it a big thing, and it's that's how we communicate what we are and what we solve. And now, by the way, do you know this meme where on the left side you have this dumb guy, on the right side you have the super smart guy, and in the middle you have like the bell curve? Do you know this meme?
Yeah, but it's the same guy on the left and the right, and then like the dumb guy, the dumb guy. No, is it? I know what
No,
meme you're
no,
talking about. Hold up.
no. You have like super dumb on the left side, and you have super smart on the right side, and then in the middle you have like everybody else.
Yes, 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 I do.
So the dumb guy on the very left, he will be like, just say what your biggest competitor does and make it open source, because you're dumb, you have no fucking clue. So let's just say like, okay, we're doing, yeah, exactly this. So on the left side, it's like, just copy Apollo, okay, and then on the right side, it's also just copy Apollo.
Yeah, but
And
look,
in the middle, it's like, okay, do some like super sophisticated hero whatever, but the dumb guy and the super smart guy, it's really just, okay, Apollo Federation open source it, and that's everything.
I mean, this one is a perfect example. Like, I just do whatever I feel like. I visualize my future, make a 10-year vision, set smart goals, break those down into productive daily routines. Discipline beats motivation. And then top 1%, I just do whatever I feel like. Apollo Federation, like, it's kind of funny. People overcomplicate things a lot. Like, usually the simplest answer is the right answer, but I really like that bell curve meme. And it does make sense. Like, we got pretty attached to the things that we build, but it's human nature. Devs build it, they feel close to it. It's the same thing if you build a house and somebody comes and is like, wow, your house sucks. So I get it. But today, we have a lot of topics to discuss. Some of the topics we're going to be discussing today is Jens wrote a blog post on OpenAI and GraphQL, so I'll share his post in a little bit. This one was funny. I think we should start with this one. This will be so funny to rant about because Apollo is breaking their own principles. I want to talk about the principles of GraphQL and how Apollo is breaking them. That one's going to be an interesting one. This one I was pretty upset about, which was some stupid article from futurism.com. They said, learn to code is backfiring, and there's a high unemployment rate for computer science grads, basically saying maybe learning to code is a mistake computer science people should be wearing. So we'll talk about that one. And then this was a cool post that don't let an LLM dumb or dull your creative edge. It is something I am seeing. Funny story. I sent a really good article, like it's maybe 50 pages, but it's a fantastic article on AI to my friend. You know what he did? He used AI to summarize it for himself. And I was like, dude, you're missing the whole point. Like, this is what the article is talking about, is that we're using AI to dumb ourselves when you should read the article. Like, can we not read 50 pages anymore? But we'll talk about that when we get to that.
You know that there was a time in the past when we were reading books, but nowadays we're too lazy. We're just summarizing books.
Okay, so I still read books, by the way. One of the best things you could possibly do. But let's start with the rant about Apollo. I think that one will keep the interested viewers. But
by the way, just a question: like, at what stage should we stop ranting about Apollo? Like, is it becoming boring, or
I don't think it could ever be boring. It's kind of fun. But I mean, it's startups. What's funny about a startup? I'll give you guys a little hack. When you're the smaller one, you can do whatever you want. Because you can, it's like a big brother, you know, you can annoy your big brother, and your mom's like, okay, whatever. But as soon as the big brother punches down on you because you're smaller, everyone's like, whoa, man, whoa, what are you doing? So as long as we're the little brother, we can keep doing this. And it's true. Like when, do you remember when Superbase was messing with Google? Someone said, good evening, sir. I'm from India, and how can we develop AI and robotics? I'm
great
not sure.
conversation?
I'm definitely not sure on that one, but we can try to touch it. But today, what we're going to be going over is just the principles that Apollo kind of published. Jens, walk me through this. Hold up, let's start right here. This is called Principled GraphQL. When did they build this, by the way? This was a while ago. So written by Joff and Matt. So this is the CEO and the CTO. And to be honest, this is a great idea. What they've written out. But Jens, you've probably read this a couple more times more than I have. What was the point of this?
So I think this is. By the way, can you take a note? I need to take a note. So, because we need to rant more about Apollo. Strategy question mark. Okay, I wrote down strategy question mark because I yeah, I just remind me of strategy question mark. All right, so principled GraphQL. I think in general, principled GraphQL it's a fantastic idea from the two founders of Apollo, essentially. And I think this exists for many years, and more or less, Matt and Geoff they created like 10 principles to somehow create like a strategy, or to have like, I don't know how you call this. Is it like a memorandum, or what kind of title would you give it? But just say
It's like a manifesto. Like it's a manifesto.
like a manifesto. Like, okay, follow these 10 rules, guidelines, whatever, and then you will have you will do GraphQL the right way. That's more or less it. And I think it came at a time where Apollo was very much like leading the space. Like, here what they say, like over 90% of GraphQL implementations use their software. By the way, this is actually, like, these days it might even be true, but it's only true because Apollo server and client, and probably like almost everybody is using that. But I think the more important question is, like, what federation stack are people actually using? And like they said, this is it's inspired by the 12 factor app. Do you know 12 factor?
No, I just changed the screen. Can you see? Okay, perfect. So
Yeah, we see
well,
it. So when I was younger, 12 factor, it was like 12 rules that gave you like a pretty good structure on how should you build microservices. Like, how you handle dependencies, how you do configuration and everything. And yeah, it was like some years ago. This was pretty decent, and I think Matt and Geoff they wanted to do a similar thing for GraphQL, so that makes sense.
It makes sense. And so I like what you said though. So 90% of GraphQL implementations. You know, it's funny though, since 2015, I graduated high school in 2015.
Yeah,
It is,
time has
they have
passed.
been around for a while. And so they have these, let's go through the 10 principles and then let's dive into the one that you said that they're breaking, which is interesting. But let's start with OneGraph. So OneGraph, your company should have one unified graph instead of multiple graphs created by each team.
Yeah, that's a funny one, because one thing that stands out immediately. By the way, you can stay on the overview. I think that's easier for us to go through. But if you stay on the overview, the first 2 points: one graph and federated implementation. As a company that yeah, tries to bring everybody to federation, that's kind of like, yeah, you know, more or less, that's how you do it. And the super interesting bit is with Apollo connectors, you might be thinking that somehow they are even breaking the second principle in some way, because the federated implementation, it somehow says you should have subgraphs that are federated, or your subgraphs should be, or your supergraph, it should be split into multiple subgraphs. And what we're now seeing is that many companies who have like legacy REST APIs or whatever, they didn't like this abstraction where they had to run and deploy a subgraph that
Yeah.
then connects to the microservices, to the REST APIs or whatever. And so I think Apollo is showing with their connectors approach that the community wants something different, that the community is actually thinking more like a monolithic approach. Like the community is more interested in yeah, maybe it doesn't have to be like so federated, maybe sometimes, but not always. For example, this is also something I learned from Netflix. Like initially, Netflix built multiple subgraph services per team, but they then realized that this is a little bit too much. It's too complex, and they are now paddling back in the direction of like more one subgraph per team. But with connectors, if you think about it, connectors is again that you just have the supergraph schema. With the connectors directives, you directly connect to REST APIs. So at the end of the day, you don't really have subgraphs anymore. It's a monolith now, and the monolith connects to microservices through directives, which leads to the question, yeah, why federation? Is still federation the right way to go? Which I also have like opinions on, but that's the first two. So we have one graph, we have federated implementation. By the way, I still think there's a lot of value in federated implementation. The third principle says track the schema in a registry. I think that is the most simple one, and it is very much proven that we absolutely need a schema registry, but not just to track the schema itself, but also the clients and how they use the schema. I think that is probably like one of the most powerful concepts. I pause here for a second. Maybe you have some remarks.
No, it's just interesting. I'm curious to when this came out. They didn't put a date on this, but I wonder when they put this out. This is obviously definitely before REST connectors. And so, I mean, I would agree with
Yeah.
everything that you've said here, the schema registry being important, but let's go a little bit further into here. So, where is it where they start to contradict themselves? Is it in point 4 or 5?
Click on point 4, abstract demand-oriented schema.
Okay, here we go. Oh, it actually goes down, which is nice. Okay, so it says the schema should act as an abstraction layer that provides flexibility to consumers while hiding service implementation details.
Okay, can you read like the first 2 sentences of the first paragraph?
Yeah. So a large part of the value of GraphQL lies in providing an abstraction between services and consumers. So the schema should not be tightly coupled either to a particular service implementation or to particular consumers as they exist today. By keeping implementation details out of the schema, it should be possible to refactor the service that implement the graph. For example, transitioning from monolith to microservices or changing the language in which a service is implemented without disturbing apps in the field.
Okay. Can you open another browser where you just search for an example of Apollo connectors?
Yeah, one sec. Apollo connectors. Maybe we could just go to their website. I think they have a code example on their website, but it's kind of weird. Hold up. Let me know if this works for you. Let me share my screen. Can you see the code example here?
Yeah, it's not perfect. Do you have one where you can see it in more clarity?
Is this okay?
No. Can you go to the docs?
Yeah. Where are the docs here? Explore pre-built. Where are the documentation? Okay. Why use connectors?
Click on
Connector
getting
example.
started. Yeah. Okay, that's a little bit tiny. Do you have like a bigger one? Product. Click on getting started. Quick start.
Where do you see that?
Just quick start after getting started.
Quick start after getting started. Why don't I see that?
Left in the menu. You have getting started and then you have quick start. And then
okay, there we go. Okay, so create a graph, explore example, tiny query, adding a new field. Maybe go further. Connectors playground. Come on, give me a good example, guys. No, I think we're gonna.
Can you go to pre-built connectors?
Pre-built.
Connectors library, pre-built connectors. Okay,
Which one do you
maybe
wanna
go
see?
to OpenAI. Is there somewhere the code for it?
Not really. No, it's just a mutation.
Okay, one sec.
One sec,
I'll find you
guys.
something.
Let me look for it too, guys. In the meantime, where's everybody calling out from while we find this example? And then we can go through it more. But right now we're discussing some of the principles that Apollo has broken in their original manifesto. Let me see if I can. You might hear some typing.
Okay, I think I found something good. I send you the link.
Okay, one sec, guys. Okay, here we go. Okay, this is a decent example. Give me a sec. Share my screen. We see it?
Okay, perfect. So let me just reiterate because I have this on this other screen. So a large part of the value of GraphQL lies in providing an abstraction between services and consumers. So the schema should not be tightly coupled either to particular service implementations or to particular consumers as they exist today. By keeping implementation details out of the schema, it should be possible to refactor the services that implement the graph. For example, transitioning from a monolith to microservices or changing the language, etc., etc. Okay, so if we think about the graph as this abstraction layer, this means that the graph on the one side, it should be oriented towards the clients, and it should be abstracted in a way to enable many different use cases. And then on the other side, we should be able to move the implementation from one service to another, or rewrite it in a different language, in a different stack, or just completely change things. And I think that this principle is very much broken with the connectors approach. So first of all, what the principle states is that we should not mix the schema with implementation details. And if we look at the schema here that we have this type price, then we have the key, which I think is fine. We define the price as an entity. And now we have the connect directive. And with this connect directive, we're essentially coupling the implementation of this entity, or the loader of the entity. We couple this to a REST API. And so now if we want to change this REST API to a gRPC API, or we change it to SOAP, or I don't know, we make other changes, it essentially could mean that we cannot implement the exact same contract anymore. Like, currently we get back ID, active, currency, unit amount. And this is mapped in the selection, because we get back from so we have a mapper function in the selection in line 11. So there's some level of abstraction, but at the end of the day, we're kind of really bound to two options. Like, either we can implement this with the connector, and the selection function will be enough to map this to the REST API, or at a later stage we have to implement it with GraphQL. And that might be a limiting factor. If you scroll down to line 25, we see a little bit more. So for example, here you can see that we load products with the HTTP GET function from /products, and then we have a mapper function. So we have ID name, and on price we have the ID, which is default price. And so now just imagine that in the future we want to change the REST API, and we would not get the price like this, like it or the price ID, it would come from another place, or whatever. Would we be able to make this change without somehow breaking the schema in the future? Like, this is such a tight coupling in this case, that I would be worried that we might eventually run into issues. And at the second time, what I don't like about it is, Stefan, I know you're like not the deepest federation expert, but if you look at line 25 and between line 25 and line 39, like, how many lines are relevant for the graph, for the structure of the graph?
For the structure of the graph?
Like, which lines are relevant that tell us something about what the API is doing for the consumer?
1, 2, 3, 4. 4 lines.
Which three or four lines?
So it's a query, products,
Yep.
where we're getting it from, and what we're getting. Which is
That's
this.
not something but that's defined in the product. So really, what you need to know as a consumer is its type query and its products, and that returns a list of product. But everything from line 27 to line 39, it's just noise. This is essentially backend code. Why is it in the schema? Why do we make it harder? Because I think what we have learned over the last few years is that GraphQL it's mainly driven by front end guys, okay?
Yeah.
And front end guys, they are like, hey, I need this query, I need that data, and they might even be they might even be capable of designing a little bit schema or making some changes to the schema contract. But they don't want to worry about, is this coming from a REST API or something? And by mixing connect directives into the schema here, from my point of view, what we're doing is we're making it harder for front-end guys to think about schema and get involved, because there's so much noise. Think about a use case where you have like 10 root fields, like not just products, not just one field, but you have 10. So 10 times, like, what do we have? Like 25 to 39. So 10 times, and then for each call, like 15 lines or something.
Damn.
It's
Yeah.
just so much
Ridiculous.
noise.
Question though. Down here, we have the legacy approach. Let me pull it up. So it said this is how you used to do it, right? This pattern is cleaner than the legacy approach of creating an inaccessible field with entity true. What does that mean? So prior to V0.2, you could only add connect to fields and use entity true to resolve entities. What does that mean? Was connect before, or is that just part of their REST connectors? I'm not sure what this means, by the way.
No, I think that was their previous approach with connectors. So they probably changed something already in the spec. Yeah, that is okay. That is another one interesting problem. Can you scroll back up again? Okay, so here, yes. So what's interesting is, can you scroll a little bit up?
Yes.
Okay, so here we have price. Yeah, the interesting bit is you have because this is something I also figured out about after digging a little bit into connect directive and entities. So one problem you have is, if you define this subgraph with the line 7 type price, this is, you define an entity. So another subgraph can jump to this subgraph and grab the price entity with the ID field, and then add other fields like active, currency, unit amount, etc. Okay. So the problem is, for this to work, you need to add a root resolver to jump to this. You need to have an entity resolver to jump to the subgraph. So if you scroll a little bit down,
okay,
to this legacy approach thing, scroll more. Yes, you see here, this is you need to have a query field. It takes an ID and it returns the price, and they have set entity to true. And this is something, it already smells, because on the one side, no, I say smells because it's like a cold smell, okay? But yeah. So my point is this: you have this price field, it gets an ID, it returns a price, because you need to somewhere define an entity resolver that gives you the price for an ID, so that this can behave like an entity. But at the same time, you don't want to expose this field to the clients, because this should be an entity resolver. Like, an entity resolver is something that's internal to the graph, not public. So to not make it public, they said, okay, let's put inaccessible on this field, because inaccessible, it creates fields that are in the schema. They are accessible to the router, but not accessible to the client. So this field price that gives you price for ID, it's not in the client schema. You cannot see it. It doesn't exist for you. But it exists in the graph because you need to have it as an entity resolver. And there lies another problem. So now you're a front-end guy, you look at the schema, you see price by ID, and you're like, why is it not in my schema? And it's because it's an entity resolver. So we're mixing the concepts here, and we're just making things like more harder. And then, Stefan, there's one more thing. I guess you
Why
don't
are
see
they?
it.
I don't.
You want to comment on something?
I'm
There's
just
another one.
Let's do the third one, and then I'll ask my question. I'll keep it in the back of my
Okay.
mind.
Do you see the big problem in line number 9?
Price ID is ID of price. No, I don't. What is it?
Okay. The problem could also be seen in line number 12.
I don't see it. What is it?
Okay. What was one of my most successful conference talks?
About the data loader pattern 3.0?
The data loader pattern. What problem does the data loader pattern solve?
You're asking the wrong guy. Reverse question, Jens. What problem does the data loader pattern solve?
It solves the n+1 problem. Do you know anything about GraphQL?
I know how to sell it.
Okay. Today I'm asking you like random junior developer. No, I'm just kidding. I'm just making fun. Okay. So here's the big deal. When the router wants to give you active currency and unit amount for a price entity, it doesn't do that for a single entity. It can do it for one, but also for 100 price entities. So that means we need to we might be sending a huge batch of requests to the subgraph to figure this out, and then we get back the information. The problem here is we have this in line number 12. We have this HTTP endpoint. It's /prices and then /args_id, which injects the ID from the price field. So that means if we fetch this field, this entity 100 times, we will make 100 REST API calls, and this will not be batched or anything, no data loader. So that's a huge n+1 problem. And this comes from having this connect directive in this shape. If you did this with Cosmo gRPC plugins, we generate we generate an RPC function that takes a list of ID arguments, and it returns a list of prices, and then the batch problem is solved.
But Jens, why would they do this then? Like, I don't understand it. It's full of problems. Why? And we say this all the time. The team over at Apollo is quite smart. But I'm a little bit confused about this. Like, if it's full and it goes back on their old principles, why would they implement something like this?
Okay, why do you do this? I think you go for this approach if you're absolutely desperate to quickly get people who have REST APIs into the graph, or maybe you have customers who don't really get enough value out of the graph, and your last straw is to not have to implement subgraphs, and then you can just continue writing your REST APIs. I don't know, but to me it seems like, yeah, I'm not sure. I like the principles. I like this idea of the schema should be abstract. It should be demand oriented, which is also another point. If you if you create your schema and you have all these connect directives in the schema, what it also means is that the schema automatically kind of aligns with the REST APIs that you have behind. So that means that the way you shape your schema will very much follow the structure of the REST APIs, which for me, the question is, wasn't the whole point of GraphQL that we follow what the front end needs and not what the backend has in the REST APIs? I think if we do not have an abstraction layer where we can write custom mapping code, where we can clearly split between this is what the consumer side wants, this is what the backend side has. I think if we don't have that, it won't work.
I mean, there's a lot we can go on. I don't want to do the whole time where we rant about some of the principles that Apollo is broken. I think it's really interesting just to kind of go back and see how people change. Overall, though, Jens, if you look at Principled GraphQL, would you agree with the 1 to 10 principles to this day, even though that some things have changed? Or would you add something else, a different principle from your end?
So I very much agree with abstract demand-oriented schema. Agile approach, I would probably rename it a little bit, but I think I understand what they mean. Like change your schema over time, that's fine.
Yeah.
Use graph metadata to empower developers. Yes, absolutely. Access and demand control. I think that's also fine. Structured logging. I don't know why it's really here. It sounds like a filler or something. And then number 10, separate the GraphQL layer from the service layer. Adopt a layered architecture with graph functionality broken into a separate tier rather than baked into every service. Which, again, I think it's also, if you click on principle number 10, I think it's also a bit related to what we said before, because it kind of states that we want to have this separate layer. I think it's meant to talk about having this router or something. If we read the last paragraph, in some cases, this graph here will talk to the backend services using GraphQL, but most frequently the backend services are left untouched and continue to be accessed by their existing APIs, such as REST, SOAP, gRPC, Thrift, or even SQL, with the mapping from these APIs to graph objects accomplished by servers that form one part of the graph tier, which in this paragraph, again, they state you should have subgraphs, and subgraphs should have the logic to map from graph to REST, SOAP, gRPC, or Thrift, which I think it is the right idea. But I'm not sure if they still follow this principle by themselves.
Question: what is thrift? I've actually never heard of thrift.
Thrift is something similar to gRPC. It's a binary protocol to talk to services.
Is it commonly used?
Some companies use it. I think, for example, Twitter and others. I think they use that. Might also be used by Netflix. I'm not sure, but some companies do, but it's not extremely widely used.
Okay, cool. I think that was super comprehensive, and it's important to see just kind of how things change. I also think it's cool when, like a different vendor kind of weighs in on some of it. Overall, the principle's good. Connectors, as you can see, we're not a fan. I actually was talking with a potential customer this week, and he liked the overall promise, which I also agree with. We have a lot of legacy. We want to transform that into GraphQL. We can't just throw GraphQL on top of it, but there needs to be an approach that kind of can help us with that. And so the REST connectors overall idea is kind of smart, but can you just explain just a little bit more? Why is our approach different? But try to keep it away from the tech, like away from the proto buff. But like, what do we do differently to help people transform their legacy into the supergraph?
Yeah, I think the first part is when we were thinking about implementing gRPC plugins, or let's just say, because gRPC in this case is not so important, but our goal was to implement Cosmo plugins. So we wanted to find a way where we say, okay, we want to build a super graph, because in general we agree super graph has superpowers. And
Well said.
so, sorry?
I said well said. I like the way you
Okay.
put that.
Yes. So how do we get non-GraphQL, non-federation APIs into this supergraph? And for us, what we were thinking about is, okay, the abstraction of a subgraph is very powerful. Like, we have one subgraph, it's a tiny piece of the schema. We have composition that makes sure that this piece of the schema fits into all other pieces. So that's one integral part. Um, and then we were thinking, okay, how can we create a developer experience that, first of all, it keeps federation as simple as it is. It doesn't add any extra complexity. It will be open to connect to whatever you want, and you don't have to learn like directives or anything. So we were thinking about that, and what we came up with is, what if we take a subgraph schema? You just write a regular schema, you don't do any
Yeah.
special thing, and we just compile it into a protobuf spec, where for each field, like an entity field where you need an entity resolver, or a root field where you need like a root query resolver or mutation, for each such field, we generate in the proto definition, we generate a schema, or like an RPC entry. And then you can implement this, compile it as a plugin, and run it as a sidecar, like a co-process to the router, and that's it. So we were thinking about it. Okay, that's a cool approach, seems simple enough. And then we started playing, and we were quite lucky with the timing, because like, I don't know, like half a year ago, we didn't have tools like Cursor with the capabilities they have today. But today, if you have Cursor and you give it the right the right rules and the right system prompts, you
Yeah.
can tell Cursor that here is a protobuf file. Here's the current implementation in Go. And I have an existing REST API. Here's the Open API spec. Can you generate me an adapter? And that is all it takes. And after a couple minutes, maybe one or two other prompts, Cursor can write you an adapter that fills the gap between Federation contract and REST API. The schema is just a regular subgraph schema. There's nothing special, no special directive, just federation. And you don't even have to understand gRPC or anything, because we generate a protobuf file, and then we implement it with Cursor, and that kind of lets us to the question, like, from a developer experience, you have a demand driven schema. We have a complete abstraction, because the schema, it has no influence from the REST API. It's just what the client side wants. And in the implementation, we can write any code we want.
Yep.
So that means we can map this to a REST API today, but tomorrow we can map it to a database, SOAP, Thrift, whatever we want.
Whichever you
Everything
want.
is possible. And so, yeah, this is the principle number 10. And I think, I don't know, maybe we're following the principles more than anybody else.
No, well said. And we get that actually a lot, that we do follow the specification of GraphQL a little bit more stricter, and that we do follow the principles. But I like the approach. We do have 10 minutes left, and I do want to bring up one more topic, which, let me share my screen. And I think this one's interesting, especially for you, Jens. So for those of you that don't know, Jens is a self-taught developer. I studied computer science and economics. Jens studied business psychology, statistics. What else did you study? That's the
It's a
joke,
lot
by
of
the
common.
way. We have an internal joke with Jens. Every time he wants to prove a point, he's like, "Well, I studied statistics, and here's the answer." Or I studied psychology. Here's why this is the answer. So Jens actually has how many degrees you have? 15, 16 or something?
All of them.
Exactly. But this article, I read it. I thought it was ridiculous. So, learn to code backfires spectacularly as comp sci majors suddenly have a sky high unemployment rate. Also, I think this quote is ridiculous. Every kid with a laptop thinks they're the next Zuckerberg. I don't know who wrote this, but it looks like learn to code push is backfiring spectacularly for those who bought in. So, there's a recent increase. It went up from the recent grads over have a 5.8%. It went up by 7.5%. Unemployment rates in the computer engineering field are 9.4 and 7.8%. This article kind of annoyed me. Apparently, our field is dying. It's kind of ridiculous, which I can't understand a little bit why somebody would write that. But the whole point of the article is just basically saying how with AI and everything that everything is kind of sky high and learning to code is now backfiring. I wanted to get your feedback on this, especially being a self-taught developer. Do you think learning to code is the wrong thing to do for the new generation, people that are studying now? Should they get into technology? Will AI wipe away their opportunities? What is your take on it?
Yeah, I also read the article. Didn't like much of it. I also think every kid with a laptop thinks they are the next Zuckerberg. I think these days are long gone. Like it's not like this kind of gold rush mentality anymore. And then the whole point is AI destroying the jobs, and is it taking away the jobs? If I look at our own company, we're all leveraging AI, and we also had people come in and find their way out again with and without AI. And I would say what AI has changed is, and by the way, I don't even like the term AI. Let's just be more specific. Let's say LLMs.
Yeah.
LLMs generating tokens. I think they are getting much better every day in generating code. But what I think it's proven multiple times now. Also, for example, underscored by a recent article, a research paper from Apple, stating that reasoning models don't really have reasoning. If you give them a problem that they haven't memorized in their learning data, they will not be able to reason about it. They will simply fail with the problem, which it I think this is the most important point you need to take away when you listen to this podcast or think about this learn to code thing here, this article. I think the biggest takeaway is, if you're a very good developer with LLMs, you can focus more on strategic parts. You can focus more on high level coding and less low level coding. But if you are not good at doing good architecture, good high level thinking, good problem thinking, then also AI is not able to help you. And AI is not replacing jobs or something. AI is probably, or LLMs, they are probably replacing or killing like extremely boring jobs. But other than that, I think AI hasn't changed much. There's a probability that one of the underlying patterns for this article could be, maybe in the past we hired too many developers, or maybe
Yeah.
too many developers were interested into getting into this field. Even people who don't really care, who just want to make money. And yeah, I think if you're a good developer, if you care about your craft, I think nothing really has changed, except with LLMs you now have pretty awesome tooling that solves boring problems, and that makes us more efficient and lets us generate more output faster.
You hit such a good point. So, if you remember during COVID, like 2020 to 2023, we called it the ZERP era. It was in a zero interest rate phenomenon. Like all these companies were raising crazy money. Zoom exploded because of the pandemic. Companies like Cameo and all these tech companies exploded. They were hiring developers like mad. During that time, the hottest thing that was available was boot camps. Here in Miami, so many boot camps spun up where they would teach you a basic MERN stack. You would learn React, Flask, and all of a sudden you're a developer. I'm a developer. And we were cranking out developers like crazy. And people were actually getting hired because people were just hiring for developers. And what I think actually happened is the ZERP area went down. 2022 to 2024 was kind of a dead era for startups. It was really hard to raise. And there was a lot of layoffs. And it wasn't layoffs because of companies doing bad. It was layoffs laying off the people that they hired in 2020 to 2023, which was not the best candidates because they were coming from just quick learning. They wanted to get into tech because it was this big boom. And I think what AI is doing is it's actually raising the bar because you can do a lot with AI, but there's also a lot you cannot do with AI because it's what you said, LLMs, and it's based on the feedback and the input that you give them, but it cannot reason. It cannot solve hard architectural problems. It can't do what Dustin does. It can't do what David does. It can't do what you do when we talk with these customers. And so I think AI is actually just raising the bar, meaning if you're interested in the technology, if you're interested and you love your craft and you're good developer, you will always have employment opportunities. But I don't think AI is firing people or helping people out. I think it's still important to learn to code. I think it's one of the best skills you could possibly learn.
I really like one of your points, like how you say it's raising the bar, because I think there's a lot of truth to it. If you think about it, like 5 years ago, you would have gotten a job if you can read a Jira ticket. Like back then, it wasn't a linear ticket, it was a Jira ticket. But if you could read a Jira ticket and write HTML and JavaScript, or maybe
Yep.
you can write React to implement the front end code to do what the ticket states. I think 5 years ago you would have gotten a job with this kind of skill set. And today, with LLMs, you can write a prompt and it will generate the React code. But if you give people like a more complicated task, the people who could write this little bit of React, they would then fail. So you're exactly right. So the bar is now at a different level. Like just writing a bunch of React, you're not a programmer anymore. That's what LLMs can do. If you want to be a programmer, you need to, yeah, you need to be able to do more high level, more complex stuff.
Yeah, and like back then, if you could write a little bit of React, a little bit of stuff, very minimal. In America, you can make a good salary, 60 to 80,000, just starting, just because you
Like you,
knew a
right?
little bit
You
of
had
code.
such a
No,
job in the
that's
past.
what I'm saying. Like I was not very good at React. I knew a little bit of React. I had a computer science degree and I was able to jump and get a degree or a job very quickly. Right now with LLMs, marketing people with zero knowledge can make changes to the website. They can change React components. They can build their own React components. Might be a little bit trial or error, but the thing is developers are still going to be a very highly paid field because the best developers cannot do LLMs cannot do what the best developers do. And so I stand by my point. I really think it's a good one. Is that the overall bar to enter into the field has just gone up higher because of AI. And I don't necessarily see that as a bad thing. I think it's actually quite a good thing because it pushes us to be even better.
Yeah. I mean, look at our tech stack, for example. Um, it is super simple on our website, like our marketing website. It's a static website. You want to change the hero? Okay. Go to the component does the hero thing and then write some cursor stuff and tell cursor to change it in some way, and it will do it. It will be fine. But go into Cosmo and like pick up one of the issues of one of our customers, like real issues, like from enterprise customers, where you have to touch a bunch of things, back end, front end, maybe add a new index to ClickHouse or whatever, and it quickly gets to a level of complexity where an LLM can do absolutely nothing, where you have to coordinate with different team members, and then you look into analytics, like who's using that feature, etc. Like the whole process of software engineering is just so complex. Like, and that's the thing. Software developers, they are already like so busy coordinating with teammates, pull requests, reviews, writing the right tests, end-to-end tests, deployment, Kubernetes. Like there's already like so many problems. Like actually we're welcoming LLMs because they can help us like make one boring thing, writing code, make that simpler. Because honestly, I think by the way, you can unshare us, but I think one of the big parts is that software engineering, it is, for me, it's not so much about writing the actual code. It's more about taking a feature requirement or taking requirements from customers and figuring out what is a good architecture to do it. Is it even a good solution in the first place? So it's about solution engineering. It's about working with the customer, figuring out like how can we do it, what is a great developer experience. One thing that a lot of people say that LLMs often lack, it's taste. Like if you build something, do it in a way that's actually enjoyable. Like, software doesn't have to suck. Build it in a way that's actually cool and easy to use, and that helps the guy in the end who's using the software to get the job done faster. And like there's so many things. Once you have built it, or even before you build it, you can think about how can I educate him on it? How can I create content on it? Documentation. You need to properly document the feature. What is the usability? And like there's so many things. Then you have to bring it into a sprint, or you have Kanban. You have to prioritize things. When you prioritize things, you have to coordinate with other team members, maybe with other teams. It can affect one or more components in the stack, so you have to coordinate how to roll out and everything. So again, like there's an infinite amount of problems, many of which LLM cannot solve. And so yeah, I think every good developer will welcome this current ongoing trend with cursor and whatnot, because it makes our lives easier.
No, well said. And I think it's a great place to end the podcast at. But guys, if you're looking for a great job and you're a great engineer and you want to work on some interesting problems, consider working at WunderGraph. We're growing. We're working on some very fascinating stuff. You're very close with the customers, and we welcome AI. Everybody on the team uses AI, but if you're relying on AI too much and you don't have the skills to back it up, this might not be the place for you. There's some really, really good technical people that work here, and we're very lucky to have them. But guys, this was a fantastic episode. Thank you so much for joining us. And Jens, what's the good thing?
The good thing is you are back next week. I'm on vacation next week, so I won't be joining you, and you need to figure out who will share the session with you.
I'll find a guest. But the good thing is I'm back next week. Jens, enjoy the vacation. Thanks for joining us today, and we will see everybody next week. Bye, guys.
Ciao. Bye-bye.